Okay, so now we're going to continue with some more of these formulas here. In this first integral, you'll see that I have x times 2x plus 5 to the negative 1 power dx. And notice here I have a formula for that exact integral, x times ax plus b to the negative 1 dx. So I'm just going to apply this formula with the a being the 2 and the b being the 5. And so the result of this would be x over a, so that would be x over 2, because 2 is a, and then minus b over a squared, so that would be minus 5 over 2 squared, so that'd give me minus 5 over 4, and then times the natural log of the absolute value of ax plus b, so that would be the natural log of the absolute value of 2x plus 5, and then plus a constant. Okay? And now the next one's not too difficult either. You have dx over x times the square root of 2x plus 4. And so here I found a formula that looks exactly like it. I have dx over x times the square root of ax plus b. So if we just assume a is 2 and b is 4, we can use this formula. And so using this formula, we get 1 over the square root of b, which would be 1 over the square root of 4. So that's going to give me the 2 right there. So that would give me 1 over 2. And then times the natural log of this absolute value of this huge fraction here. And the numerator of this huge fraction would just be the square root of ax plus b. So that would be the square root of 2x plus 4. And then minus the square root of b. And since b is 4, the square root of 4 is 2. And then in the denominator of this fraction, you have the same square root of ax plus b here. But then you have plus the square root of b, and so that would be plus the square root of 4, which is 2. And then you add your constant. Okay. Now the next one is very similar to this one that I just did. The next one, the only difference is in the square root I have 2x minus 4 instead of 2x plus 4. But guess what? We have a formula for that one too. So the formula for dx over x times the square root of ax minus b would be 2 over square root of b times the arctan of the square root of ax minus b all over b plus a constant. So now I can apply this formula with a equal 2 and b equal 4. And so if I apply this formula, I get 2 over the square root of b, so that would give me 2 over square root of 4, and square root of 4 is 2, so I just have 2 over 2, so those would actually end up canceling. And then I have the arctan of this square root. Well, that would be the arctan of ax minus b, which is the 2x minus 4 here. So I'd have arctan of 2x minus 4 all over the b, which is 4. Now, and then plus a constant. Now, to finish this up, what I did here is I just factored a 2 out of these two terms and then canceled it into the 4. So if you factor 2 out of this, that'll leave you with x minus 2 in the numerator, and then I took the 2 and canceled it into the 4, and it gave me a 2 in the denominator there. So my final answer is the arctan of the square root of x minus 2 over 2 plus a constant. Okay? All right. Now, the next one here, I'm actually going to integrate x times the arcsine of x dx. Now I actually have a formula that looks more complicated than this, but that's because this formula is actually for any power of x. So this formula here is actually for x to the n, but I'm doing a simple one. I just have x to the first power. So in my example, n would be 1. So it'd be x to the first. And then also this formula allows you to allows for in case you have a constant times x, but in my example I don't have anything other than, well, you can think of that as 1 times x. So actually in my example the n is 1, and also so is the a. The a would be 1. Okay, so now let's see what happens. How does that formula work? So if I have x to the first times the arcsine of x, then that would be x to the n plus 1, so that would be x to the 1 plus 1, which would be x squared, over n plus 1, so it'd be over 2. And then I'd have minus a over n plus 1. So now remember, my a is 1, so I'd have minus 1 over n plus 1. And then times this integral. And this integral is x to the n plus 1 dx times the square root of 1 minus a squared x squared. So let's see if I can get that integral. So let's see, x to the n plus 1, that would just be x squared, and then over the square root of 1 minus, now remember my a is 1, so that'd be 1 minus 1 squared times x squared, so that's just going to be 1 minus x squared. So now, what I want to do now is I want you to focus on this integral here, and then this formula here. So I'm going to actually use this formula and apply it to this second integral. So I'm going to go ahead and copy this x squared over 2 over here. I'm going to bring my minus 1/2 over here. And now in the parentheses, I'm going to put the result of this integral. So let's see what that integral would be. Let's see, the formula says I would need a squared over 2. Now, my a is 1, because a squared is 1, so a would be 1. So my a would be 1, so a squared over 2 would just be 1 over 2. And then I have an arc sine of x over a, but again, a is 1, so that would just be the arc sine of x, because x over 1 is just x. And then minus 1/2 x, so there's the minus 1/2 x, and then times the square root of x, a squared minus x squared, and so my a squared minus x squared is just 1 minus x squared, and then plus c. And the last thing I did here was I just went ahead and distributed the minus 1/2 through here, and got my final answer. Okay, there was a set of parentheses here that shouldn't have been here. So you can see here that if I bring this down, I get x squared over 2, and then distributing the minus 1/2 through here, minus 1/2 times 1/2 is minus 1/4. So I have minus 1/4 times the arc sine of x, and then distribute the minus 1/2 through the next term, minus 1/2 times minus 1/2 gives me plus 1/4. So I have plus 1/4 x times the square root of 1 minus x squared plus c. So that's how you apply that formula. Now, let me go ahead and show you a reduction formula. There's a lot of different reduction formulas. But basically, what a reduction formula does is it tries to reduce generally a power down to something that you can handle by maybe some other means. So this reduction formula is for if you have the tangent function raised to the n and you want to integrate that. Well, the formula for this says if you want to integrate tangent of x to the nth power, that would be 1 over n minus 1 times the tangent function to the n minus 1, and then minus the integral of the tangent function to the n minus 2. And here's another formula for the log, and that you can use that one on that practice problem that I gave you down here. But let's go ahead and apply this formula for this problem, tangent to the 5th x. So using that formula, n would be 5 right there. So if I do 1 over n minus 1, I'd have 1 over 4, and then tangent to the n minus 1 power, so that'd be tangent x to the 4th power. Then I'd have minus the integral, and then I'd have tangent, and I reduce the power by 2, so tangent to the 3rd power. So now I'll go ahead and copy this here, and then the next thing I'm going to do is I'm going to apply that same reduction formula to this. So let's focus on this integral here for a second, and notice I put it in parentheses here. So now let's worry about tangent cubed x, and let's apply this same formula. So now n is 3, so I'd have 1 over 3 minus 1, so that would be 1 over 2, and then tangent to the 3 minus 1 power, so that would be tangent squared x, and then minus the integral of tangent, let's see, to the 3 minus 2 power, so that would just be minus the integral of tangent x. Okay, now what I'm going to do now is just bring this term down, so I have 1/4 tangent to the 4th x, and then distribute the minus here, and so I have minus a half tangent squared x, and then distribute the minus here, minus a minus would give me plus the integral of tangent x dx. Now we have a formula for integrating this tangent x, so now we've got this reduced down to something that we know how to deal with. So you can go back and look up the formula for integrating tangent x, and you can see here that it's this minus the natural log of the absolute value of cosine x. So just replace that integral with the minus the natural log of the absolute value of cosine x, and now you've got the entire function integrated. And obviously don't forget to add your c at the end. Now, like I said, this other formula here, I gave you this one, so the natural log of x raised to the nth power, that integrates to x times the natural log of x to the n, and then minus n times the natural log of x to the n minus 1. So you could similarly apply this to actually integrate this formula, natural log of x to the 4th power dx. And so you can do that as a practice problem and see if you can get the same answer I got here. And if you don't, either you're wrong or I'm wrong. But anyway, give that a shot and see what you can do. Now, I just want to finish this up with a note about non-elementary integrals. The development of computers and calculators that find antiderivatives by symbolic manipulation has led to interest in determining which antiderivatives can be expressed as finite combination of elementary functions. And these are the functions we've been studying, and which cannot. Integrals of functions that do not have elementary antiderivatives are called non-elementary integrals, and they require infinite series or numerical methods for evaluating them. So one thing I do want to warn you about is that do not try to integrate one of these non-elementary integrals, because basically it's been proven that these integrals cannot be integrated. And so if you do find a way to integrate them, then you'll probably be rich, because nobody else has been able to. So here are a few of the integrals that can't be integrated. So like sine of x squared, square root of 1 plus x to the 4th. And I got these by Googling, so if any of them are not non-elementary, then I apologize. But these are some examples. 1 over natural log of x, that can't be integrated. The natural log of x dx, that can't be integrated. Sine x over x dx, that can't be integrated. So there are functions that can't be integrated by algebraic methods, but now they can be integrated by using what's called an infinite series to approximate them, or using what's called numerical methods. So that's sort of like kind of hand cranking the answer out for you. Okay, so that pretty much finishes the lecture over integration by using tables or formulas.